Students. So previously we have solved MCQs on some basic concepts of chemistry, structure of atom and periodic table, isn't it? Now see, I'm here with a new chapter, that is the fourth chapter of 11th standard, that is chemical bonding and molecular structure. See, I could have gone directly with the multiple choice questions of this chapter also, but this chapter is a laborious chapter and it needs lot of understandings. Lot of concepts should be learned in this chapter. There are so many concepts, okay? There are so many concepts to learn in this chapter. So I thought, rather than directly going with the multiple choice questions of this chapter, let me just brush up this chapter so that you will memorize all the concepts and then we will start with MCQs. Is that fine, students? Okay. So shall we have a quick glimpse of what we have got to study in this chapter? I'm not going to go in detail about all the topics. I'll just brush up. Okay. Simple, because I want you to memorize the concepts that you have learnt in 11th standard. Okay, yes. So what are the different concepts that we have got to study here, students? Yeah, let me first check out all the concepts and let us discuss all the concepts one by one. Is that okay? Yes. So students, here we will start with causal Lewis approach. This chapter starts with causal Lewis approach. Causal Lewis approach. Here we will study Octet Rule. Very important, students. We have to discuss about what? Octet Rule and the limitations of the Octet Rule. Then after this we will discuss different types of bonds. Different types of bonds. Types of bonds. Types of bonds. So here under different types of bonds we will learn about ionic bond. Ionic bond. Next we will talk about covalent bond. Covalent bond. Then coordinate bond. Coordinate bond. Okay, and hydrogen bond. And hydrogen bond. Okay, 4 different types of bonds we will study in this chapter: ionic bond, covalent bond, coordinate bond and hydrogen bond. Okay, here in covalent bond itself we will study something called as Fajan's rule. Fajan's rule, which is related to both ionic bond as well as covalent bond. Fajan's rule, isn't it? And the next concepts we will completely emphasize on, okay, a very important type of bond that is called as covalent bond. The next upcoming concepts, okay, that we are going to discuss will be completely on what? Covalent bond. Well, students, here the next topic that we are going to study is about dipole moment. Dipole moment, very important. We can expect a lot of questions on dipole moment. Dipole moment. Okay, well, this is basically for what type of bond? Covalent bond. Okay, and for covalent bond we will have 3 theories to explain the nature of covalent bond. We have 3 theories to explain the nature of covalent bond, the geometry of covalent compounds, etc., etc. Which are those 3 theories? That is valency shell electron pair repulsion theory, VSEPR theory. VSEPR theory. Okay, valency shell electron pair repulsion theory. And then we have valency bond theory, VBT, valency bond theory. And the last theory that we are going to discuss is molecular orbital theory. Molecular orbital theory. All the 3 theories are very important. And in valency bond theory we come across a concept called as hybridization. we come across a concept called as what? Hybridization. Hybridization. Understand, students? Okay, so we shall emphasize a discussion on all these concepts. We will stress more about all these concepts. Okay, that is causal Lewis approach, which we call it as Octet Rule. And I forgot to tell you, yes, here we should learn about, okay, yes, what is it? Okay, what is that? Okay, we write a structure called as Lewis dot structure. Yeah, you should learn how to write the Lewis dot structure. Okay, Lewis dot structure, very important, and we should learn how to calculate the formal charge. How to calculate the formal charge, very important. These two concepts all these concepts are very important. You can expect questions on any concept because all of them are important. Okay, so causal Lewis approach, Octet Rule. In types of bonds, we should discuss the nature of ionic bond, covalent bond, coordinate bond, and hydrogen bond. Okay, under covalent bond and ionic bond, we study a rule called as what? Fajan's rule. Okay, Fajan's rule. And after this, okay, we will completely deal with the covalent bond, the nature of covalent bond, the geometry of covalent compounds, okay, the bond angle, etc., using these concepts called as dipole moment, valency shell electron pair repulsion theory, valency bond theory. Under valency bond theory, we learn about hybridization, and then molecular orbital theory. Okay, got it? Yes. So now first let us discuss about Octet Rule. Let us talk about Octet Rule. Octet Rule. Yes, students. Yeah, let us talk about the first concept, that is Octet Rule. Octet Rule. What do you mean by Octet Rule? What is Octet Rule, students? What is Octet Rule? You know, elements, that is, okay, atoms of different elements, the Octet Rule says the atoms of different elements combine to attain octet, combine to form molecules to attain what? Octet configuration. Octet configuration. Okay, what do you mean by octet configuration? Okay, in their valency shell, okay, atoms of different elements combine to attain octet configuration in their valency shell. Yes, so to attain octet configuration in their, okay, valency shell. Yes, are you getting my point? Okay, why atoms of different element combine to form compounds, or why does atoms of different element combine to form molecule? Okay, why? In order to attain octet configuration in their valency shell, isn't it? For example, okay, when hydrogen, okay, if not hydrogen, if I take sodium chloride, okay, how is sodium chloride molecule formed? Okay, sodium atomic number is 11, its electronic configuration is 1s2, 2s2, 2p6, 3s1. Now sodium will lose one electron to form what? Na plus. It will lose one electron. When sodium loses one electron, okay, its electronic configuration is going to become 1s2, 2s2, 2p6. Okay, that means look at here, it will have 8 electrons in its valency shell. Okay, when it has 8 electrons in its valency shell, it will attain nearest noble gas configuration, and hence it's going to become stable. It will become stable. Are you getting my point? Okay, when sodium lose one electron, the electronic configuration is going to become 1s2, 2s2, 2p6. Okay, that means it will attain the nearest noble gas configuration. It will have 8 electrons in their valency shell. It has 8 electrons. Valency shell means the outermost shell. In the outermost shell it has 8 electrons, and hence it becomes what? Stable. Now what happens to chlorine? Chlorine will gain 1 electron to form what? Chloride. Okay, chlorine will gain this electron to form chloride. What is the atomic number of chlorine? Atomic number of chlorine is 17. What's its electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p5. Correct? When chlorine gains 1 electron, its electronic configuration is going to become what? 6. When chlorine gains 1 electron, it becomes 3s2, 3p6. And look at this outermost shell. Okay, yes, when chlorine gains 1 electron to form chloride, its electronic configuration in the outermost shell becomes 3s2, 3p6. That means it has 8 electrons in its outermost shell. Okay, when it has 8 electrons in the outermost shell, it will also become stable. So on one side, okay, Na, on losing 1 electron, it has become Na plus, it has become stable. Chlorine, on gaining 1 electron, it becomes chloride, it has also become stable. So both have become stable. Now oppositely charged ions will attract to form what? NaCl. To form NaCl. Is it correct? This is how sodium chloride is formed. So atom of sodium and atom of chlorine, why do they combine? Why atom of sodium combines with atom of chlorine, okay, to form sodium chloride? Because, okay, sodium has the tendency to have 8 electrons in its outermost shell. Chlorine has the tendency to have 8 electrons in its outermost shell. If the elements have 8 electrons in the outermost shell, they become stable. Okay, they attain stability. Correct? Okay, so in order to attain stability, okay, sodium will give out 1 electron, chlorine will take up 1 electron. So both of them attain the nearest noble gas configuration. That means they will have 8 electrons in the outermost shell, and hence they become stable. This is what we call octet rule. Atoms combine. How do they combine? Okay, either by, okay, what? Complete transfer of electrons. Atoms combine by complete transfer of electrons, or atoms combine by sharing of electrons. So atoms will combine either of these two processes. Atoms will combine either by complete transfer of electrons, or atoms will combine by sharing of electrons. Why do they combine? They combine to get 8 electrons in the outermost shell. When they get 8 electrons in the outermost shell, they attain stability. This is what octet rule is. Okay, so what is octet rule? Octet rule says atoms of different elements combine to attain, okay, the octet configuration in their valency shell. Okay, how do they combine? They combine either by complete transfer of electrons, or they'll combine either by sharing of electrons. We will understand these two concepts in the next concept. Okay, that is an ionic bond as well as an covalent bond. Ionic bond and an covalent bond. But did you understand this octet rule? State octet rule. Atoms of different elements combine to attain octet configuration in their valency shell. But this rule has certain, okay, what? Yeah, it has certain limitations. Okay, so what are the limitations of octet rule? The questions will come from the limitations of octet rule. Yes, the questions will come from the limitations of octet rule. Nobody will ask you octet rule, okay, but the questions will be on the limitations of octet rule. Yes, students, so what are the limitations of octet rule? What are the limitations of octet rule? Yes, the first limitation is hydrogen and helium. Okay, hydrogen and helium. Look at here, when hydrogen molecule is formed, okay, how is hydrogen molecule formed? Okay, what is the atomic number of hydrogen? 1. Its electronic configuration is 1s1, isn't it? Now hydrogen has 1 electron, so one hydrogen will share 1 electron, other hydrogen will share 1 electron, and a bond is formed between the two hydrogen atoms. Okay, when one hydrogen shares 1 electron and the other hydrogen shares 1 electron, these 2 electrons belongs to this hydrogen and the 2 electrons belongs to this hydrogen also. Okay, that means the 2 electrons are shared mutually between the 2 atoms. The 2 electrons are shared equally between the 2 atoms. Okay, so that the 2 electrons belongs to both the atoms. Okay, so when hydrogen molecule is formed by the sharing of electrons, okay, now earlier hydrogen atom has 1 electron. Now when it has shared electrons and it has formed a bond with another hydrogen to form hydrogen molecule, in hydrogen molecule each hydrogen will have, okay, 2 electrons. Each hydrogen will have 2 electrons. Look at here, each hydrogen in the hydrogen molecule has 2 electrons. 2 electrons. Is there any octet configuration? There is no octet configuration. Okay, no, there is no octet configuration. There is duplet configuration. Which configuration do you say it is? Duplet configuration. We call it as duplet configuration. No, there are no 8 electrons in hydrogen atom of hydrogen molecule, but still hydrogen atom is stable. According to octet rule, if, okay, the atoms combine to form molecule, they will have 8 electrons in their valency shell and hence they become stable. But when hydrogen atoms combine to form hydrogen molecule, hydrogen atoms do not have 8 electrons. They will have only 2 electrons in their outermost shell, but still both the hydrogen atoms in the hydrogen molecule will become stable by attaining duplet structure. They don't attain octet structure, they will attain duplet structure. Even in case of helium, helium is a noble gas. Helium is a noble gas. It's an inert gas. It's an inert gas. It do not react at all. Do not react. Why do not react? Because helium is stable. Helium is stable. Why helium is stable? Does it have 8 electrons? No, helium does not have 8 electrons. What is the atomic number of helium? It is 2. What is its configuration? 1s2. Does it have octet structure? No, it doesn't have octet structure. It has only duplet configuration. It has duplet structure, but still helium is stable. Okay, even though it does not have 8 electrons, it has only 2 electrons in its outermost shell. That means helium has duplet structure, but still helium is stable. Helium is stable. So that means, okay, octet structure is not obeyed by hydrogen and helium. Okay, according to octet structure, when atoms combine to form molecule, they should have 8 electrons. They will have 8 electrons in the outermost shell. They become stable. But when hydrogen atoms combine to form hydrogen molecule, they do not have 8 electrons. They have only 2 electrons in their outermost shell. They attain duplet structure. Okay, why helium is stable? Is it because of octet configuration? No, helium is not stable because of octet configuration. There can never be octet configuration in helium. There is only what? Duplet configuration. Duplet configuration. Are we clear? Yes, this is one of the limitations of octet rule. So octet rule is not obeyed for hydrogen and helium. Now we shall consider some more, okay, limitations of octet rule. Yeah, what was the first limitation? It is the duplet structure. Duplet structure for hydrogen and helium. No octet structure. Look at the second limitations of octet structure. Certain elements, like in certain molecules like beryllium chloride, okay, boron BH3, boron trifluoride or boron trichloride. Okay, yeah, the central atom has less than 6 electrons, sorry, less than 8 electrons. It has less than 8 electrons, but still, okay, the molecules are stable. The molecules are stable. For example, if you consider beryllium chloride, which is the central atom, beryllium is the central atom. So beryllium is surrounded by chlorine. It's a linear molecule. How many electron pairs are there around beryllium? Look here. Okay, so see, 1, 2, 3, 4. What is the atomic number of beryllium? Beryllium, it's 4. Its electronic configuration is 1s2, 2s2. So beryllium is sharing 1 electron with this chlorine, and beryllium is sharing 1 electron with this chlorine. So altogether, how many number of valence electrons are there around beryllium now? There are only 4 electrons around beryllium. There are only 4 electrons around beryllium. There are only 4 electrons around beryllium. Okay, according to octet rule, when the atoms combine to form molecule, they will have 8 electrons. But when beryllium combines with chlorine to form beryllium chloride, it has only 4 electrons. But still beryllium chloride is stable. It is still stable. If you take boron trichloride, what's the formula? Boron trichloride, BCl3. Okay, what is the atomic number of boron? 5. What is its electronic configuration? 1s2, 2s2, 2p1. Look here. There are 3 valence electrons in boron. 3 valence electron. So boron will share 1 electron with this chlorine, 1 electron with this chlorine, and 1 electron with this chlorine. Okay. So now altogether, how many electrons are there around boron? There are only 6 electrons. Just count 2, 4, 6. So boron has only 6 electrons around it. So when boron combines with 3 chlorine atoms to form boron trichloride, it will get only 6 electrons in its valency shell. But according to octet rule says it will have, okay, when the atoms combine to form molecule, they will have, okay, 8 electrons. But there are only 6 electrons around boron trichloride. But still it is, okay, what? Stable. So that means I can say we will get so many molecules where the central atom will have less than 8 electrons. Less than 8 electrons. This is another limitations of what? Octet rule. Octet rule. Let me understand the other limitations of octet rule. Okay, I hope you understood the second limitations of octet rule. Yes. What about the third limitation of octet rule? Yes. Yes, look at this third limitation. Certain molecules like what? Phosphorus pentachloride, sulfur hexafluoride. Okay, they have the central atom has more than 8 electrons. Okay, it is less than 8 electrons. Here it is more than 8 electrons. Here also the molecule is stable. The molecule is stable. Here also the molecule is stable. For example, if you consider phosphorus pentachloride, okay, atomic number of phosphorus is 15. Its electronic configuration is 1s2, 2s2, 2p6, 3s2, and 3p5. So phosphorus has 5 valence electrons. So phosphorus, okay, will share 1 electron with each chlorine. 1 electron with each chlorine, like this. Look at here. Phosphorus will share 1 electron with each chlorine. When phosphorus shares 1 electron with each chlorine and forms phosphorus pentachloride, just count the number of electrons around phosphorus. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Phosphorus is surrounded by 10 electrons. More than 8. But octet rule, it says when atoms combine to form molecule, okay, they will have 8 electrons. But here the central atom has more than 8 electrons. That means phosphorus pentachloride is also stable. Okay, so that means, students, there are certain limitations for octet rule. Of course, octet rule is obeyed by majority of the compounds. 90% of the complex, 90% of the molecules will obey octet rule. There is no doubt in it. But remaining few molecules, they do not obey octet rule. They need not have 8 electrons in their valency shell when they form molecule. They may have, okay, 2 electrons, that is, they might have duplet structure. They might have more than 8 electrons, or they might have less than 8 electrons. But still, all the molecules are stable. For example, hydrogen molecule. In hydrogen molecules, hydrogen does not have octet structure. They have duplet structure. But still, both the hydrogen atoms in the hydrogen molecule is stable. beryllium chloride, boron trichloride, okay, phosphorus pentachloride, sulfur hexafluoride, all the molecules are stable. Even they don't have 8 electrons in their valency shell, they have more than 8 electrons or they have less than 8 electrons, still the molecules are stable. So these are the few exceptions of octet rule. And there is one more exception to this octet rule. For example, okay, certain molecules like molecules like okay, NO, nitric oxide, NO2 has odd electrons on central atom. For example, if you take nitrogen dioxide, NO2, it is N double bond O, N double bond O. This oxygen, okay, sorry, nitrogen dioxide is something like this. Okay, nitrogen has odd electron. Okay, look here, 2, yes, 4, okay, 6 and 1 7. Nitrogen has 7 electrons around its valency shell. Nitrogen has 7 electrons in its valency shell, but still nitrogen dioxide and nitric oxide are stable. So certain molecules have odd number of electrons in their valency shell. Okay, odd number of electrons in their valency shell, but still those molecules are also stable. So octet rule, okay, yes, as I said, 90% of the molecules will obey octet rules, but certain molecules like hydrogen molecule or helium atom, okay, or beryllium dichloride, BH3, BCl3, okay, phosphorus pentachloride, sulfur hexafluoride, nitric oxide, nitrogen dioxide, they do not obey octet rule. They either have less than 8 electrons or more than 8 electrons, or they will carry odd number of electrons. They will carry what? Odd number of electrons. So that is about the octet rule and the limitations of octet rule, students. Octet rule and the limitations of octet rule. Are we clear? Yes. Students, now let us go with the next concept. Okay, let us learn about the different types of bonds. Okay, let us talk about the different types of bonds. Okay, yes, different types of bonds. As I said, we'll be talking about what? Ionic bond, okay, then covalent bond, coordinate bond, and lastly hydrogen bond. Ionic bond, covalent bond, coordinate bond, and what? Hydrogen bond. Students, how about an ionic bond? What is an ionic bond? Yeah, ionic bond is also called as electrovalent bond. Ionic bond is also called as electrovalent bond. Okay, yes. What is ionic bond or covalent bond? Yes, just a minute, students. What is ionic bond or covalent bond? See, let me define ionic bond or covalent bond as a bond formed by, okay, a bond formed, okay, or electrostatic bond, okay. Ionic bond or covalent bond, okay, is defined as the electrostatic force of attraction. It is nothing but electrostatic force of attraction, okay, electrostatic force of attraction between the oppositely charged ions. The electrostatic force of attraction between the oppositely charged ions formed by the complete transfer of electrons, formed by the complete transfer of electrons. Complete transfer of electrons is called as what? Okay, ionic bond or covalent bond. It is the electrostatic force of attraction between the oppositely charged ions formed by the complete transfer of electrons. It's a bond formed by the complete transfer of electrons. Complete transfer of electrons. Okay, isn't it? Just few minutes back, I gave the example of sodium chloride. I gave the example of what? Sodium chloride. How is sodium chloride molecule formed? Yes, sodium, okay, will completely lose an electron to form Na plus. Chlorine will completely gain this electron, will completely accept this electrons to form chloride. Now, sodium ion and chloride ion being oppositely charged ions, we know opposite charges will attract each other. Sodium ion and chloride ion being oppositely charged ions, they attract each other to form what? Sodium chloride. To form sodium chloride. So here there is complete transfer of an electron from sodium to chloride, isn't it? Okay, sodium will completely transfer one electron to chlorine. As a result, sodium forms Na plus and chlorine will form what? Okay, as a result, sodium will form Na plus and chlorine will form Cl minus. These oppositely charged ions will attract, they mutually attract with each other to form what? NaCl. They form NaCl. Okay, so here the bond between sodium and chloride is formed by mutual attraction, electrostatic force of attraction between oppositely charged ions. However, this oppositely charged ions produced by complete transfer of electrons from one atom to the other atom. Well, what is this bond called as? This bond is called as ionic bond or this bond is called as ionic bond, or it is also called as electrovalent bond. Okay, this is also called as electrovalent bond. Well, students, under ionic bond or electrovalent bond, you should be knowing about one important definition, that is called as lattice enthalpy or lattice energy. Lattice enthalpy or lattice energy. Yeah, under ionic bond or electrovalent bond, I'm talking about the first bond. Please remember, that is ionic bond. Okay, so under this, you should be knowing one definition. What is it? It is called as lattice enthalpy. What is it called as? Lattice enthalpy or lattice energy. Lattice energy. Lattice energy. Lattice enthalpy or lattice energy. Look here, students. See, I just told, okay, so sodium will lose one electron to form Na plus. Okay, yes, chloride will gain an electron to form Cl minus. These two ions will attract each other to form what? Sodium chloride, correct? So here, when 1 mole of sodium chloride is formed, when 1 mole of sodium chloride solid is formed, okay, from its constituent ions in the gaseous state, from the constituent ions in the gaseous state. Look here, what is this? Ionic compound, isn't it? This is an ionic compound. So when 1 mole of solid sodium chloride is formed, from its sodium ions in the gaseous state and chloride ions in the gaseous state, okay, yes, some amount of energy is liberated. Heat energy is liberated. Certain quantity of heat energy is liberated. Okay, the amount of heat energy that is liberated. The amount of heat energy that is liberated when 1 mole of sodium chloride solid is formed from sodium ions in the gaseous state or chloride ions in the gaseous state is called as lattice enthalpy or lattice energy. It is called as lattice enthalpy or lattice energy. Are you getting my point? Okay, so what is lattice enthalpy or lattice energy? Let me write the definition here. Okay, let us write the definition. Okay, the amount of energy, okay, very important, the amount of energy released, okay, when 1 mole of, okay, solid ionic compound, important is solid ionic compound is formed, okay, from its constituent elements in the gaseous state, constituent, not elements, constituent ions in the gaseous state is called as lattice enthalpy or lattice energy. Okay, so when 1 mole of solid sodium chloride is formed from the constituent sodium ions in the gaseous state and chloride ions in the gaseous state, the amount of energy that is released in this case is called as lattice enthalpy or lattice energy. Lattice enthalpy or lattice energy. Students, hope you have understood. Yeah, lattice enthalpy can also be stated in a reverse way. Okay, so if I want to break solid sodium chloride into constituent sodium ions in the gaseous state or chloride ion in the gaseous state, the amount of energy that has to be supplied, okay, the amount of energy that has to be supplied to solid sodium chloride in order to break the solid sodium chloride to sodium ions in the gaseous state and chloride ions in the gaseous state, it is also called as lattice enthalpy. Okay, both are lattice enthalpy. Understood? Here, when 1 mole of ionic compound is formed, heat energy is liberated. Here, when 1 mole of ionic compound is broken, heat is absorbed. So that means in this case, lattice enthalpy is exothermic. In this case, lattice enthalpy is endothermic. Are you getting my point? So we will denote it like this: delta H lattice. Delta H lattice, here heat is given to sodium chloride solid in order to break that sodium chloride solid to sodium ions in gaseous state and chloride ions in gaseous state. Hence lattice enthalpy in this case is positive. Whereas here, okay, heat is released when 1 mole of sodium chloride solid, okay, is formed from constituent ions in gaseous state. So heat is released, therefore, okay, lattice enthalpy in this case is negative. So this lattice enthalpy is exothermic, whereas this lattice enthalpy is endothermic. Please remember this point. This is very important. This concept is very important under ionic bond or electrovalent bond. Okay. So what is lattice enthalpy or lattice energy? The amount of energy released when 1 mole of ionic compound is formed from its constituent ions in the gaseous state. Okay, so lattice, delta H lattice is negative. Okay, so it can also be defined as the amount of energy that should be supplied to break 1 mole of an ionic compound, solid ionic compound, into its constituent ions in the gaseous state. It is also called as lattice enthalpy, but in this case lattice enthalpy is positive. Okay, see students, remember this point. Okay, higher the lattice enthalpy, okay, yes, stronger is the ionic bond. Okay, stronger is what? Ionic bond. Okay, or else I can say higher the lattice enthalpy, okay, more stable is the ionic compound. More stable is the ionic compound. More stable is the ionic compound. I can define it in both the way. Okay, higher the lattice enthalpy, stronger is the ionic bond, or higher the lattice enthalpy, more stable is the ionic compound. Okay, that's great. Okay, what are the different characteristic features of ionic compounds or ionic bond? Yes. Yes, what are the different features? Okay, different characteristics, different properties of ionic compounds. Properties of ionic compounds. Properties of ionic compounds. Okay, yes, usually ionic compounds are crystalline solids. Okay, ionic compounds are what? Crystalline solids. Crystalline solids. Are you getting my point? Ionic compounds are crystalline solids. Okay, yes, usually they have high, okay, melting point and boiling point. They have high melting point and boiling point. Okay, yes, and then, okay, ionic compounds are soluble in polar solvents like water. Okay, ionic compounds are soluble in polar solvents. They have high melting point and boiling point. They are crystalline solids. They are soluble in polar solvents, and usually, okay, ionic compounds are good conductors of electricity. They are good conductors of electricity in molten state. They are good conductors of electricity in molten state and in aqueous solution. And in what? Aqueous solution. They are good conductors of electricity in molten state and in aqueous solution. Okay, so they are usually crystalline solids. Okay, they have high melting point and boiling point. They are soluble in polar solvents. They are good conductors of electricity in molten state and in aqueous solution. And one more thing to be remembered here: ionic bond is non-directional. Don't worry, I'll explain this. What is non-directional in the upcoming discussion. Okay, ionic bond is non-directional. Ionic bond is what? Non-directional. Understand this point. Okay, is that simple? So these are the few characteristic features of what? Ionic bond and ionic compounds. Okay, now what are the factors that favors the formation of ionic bond? Yeah, that is where it is important. Okay, what are the factors that favors the formation of ionic bond? Factors favoring the formation of ionic bond. Factors favoring the formation of what? Ionic bond. Okay, factors favoring the formation of ionic bond. See, I told you what should happen. Okay, for the formation, how sodium chloride should be formed. If sodium chloride has to be formed, sodium has to lose one electron to form Na plus, and chlorine should gain this electron to form what? Cl minus. Observe the formation of sodium chloride here. See, okay, I know, or we know, that ionic bond involves the complete transfer of electrons from one atom to another atom. So, okay, for the formation of an ionic compound, one species should lose the electron and the other species should gain the electron. One species should lose the electron to form cation and the other species should gain the electron to form what? Anion. Only when one species lose the electron and the other species gain the electron, there will be formation of oppositely charged species. When there is formation of oppositely charged species, they attract each other and they form an ionic compound or ionic bond. Okay, so one species should lose an electron. Okay, when does sodium lose? When do you say that any species will lose an electron? Will it simply lose an electron? When do you say that any species will lose an electron? Will some species simply lose an electron as such? No. Okay, and a species or an element will lose an electron easily only when it has low ionization enthalpy. only when it has low ionization enthalpy. When its ionization enthalpy is low, only when its ionization enthalpy is low, it will easily lose an electron. So that means the first factor which favors the formation of ionic bond is low ionization enthalpy. Low ionization enthalpy favors the formation of what? Favors the formation of a cation, isn't it? So for an ionic bond to be formed, first thing, primary condition is a cation should be formed and an anion should be formed. Only when cations and anions are formed, those two are oppositely charged ions, they attract each other and they form a bond, isn't it? Okay. So in order to form a cation, the species should have low ionization energy. Only when one element has low ionization energy, it can easily lose the electron. When it can easily lose the electron, it will form a cation. Now, of course, no doubt, if one element has low ionization enthalpy, it will lose the electron and forms a cation. But what should happen to the other element? The other element should gain the electron. Other element should attract the electron, isn't it? Other element should withdraw the electron. Okay. Only when this element gains or accepts this electron, it can form an anion. Is it correct? Only when this element accepts this electron, it can form anion. Well, no, does some species or does some element simply accepts an electron as such without any condition? No. An element will easily accept an electron and forms anion only when the element has high electron affinity. If the element does not have electron affinity, if the element does not have high electron affinity, how come it will attract the electron? How come it will accept the electron? If this element has to accept the electron, it should have high electron gain enthalpy or high electron affinity. If there is no affinity for electrons, how does one element attract the electron? How does one element accept the electron? No, it cannot simply accept the electron. It cannot simply attract the electron. Are you getting my point? So if one element has to form anion, it should gain electron, it should attract electron, it should accept electron, and that will accept electron only when it has high electron gain enthalpy or high electron affinity. High electron affinity. So what is the next factor? Yeah, the next factor is high ionization, not ionization enthalpy, high electron affinity. High electron affinity favors what? Favors the formation of anion, okay. So for ionic bond, cation should be formed and anion should be formed. A cation is formed only when the element has low ionization enthalpy, and the anion is formed only when the element has high electron affinity. Of course, so sodium has low ionization enthalpy, so it will lose an electron easily and forms cation. Chlorine has high electron affinity, it will accept electron and forms what? Chloride ion, anion. Now cation and anion will attract each other to form an ionic compound. So when we know when an ionic compound is formed, from the ions, energy is released. What is that energy called as? Lattice energy. Look, only when lattice energy is more, the ionic compound that is formed is more stable. If the lattice energy is less, then the ionic compound that is formed will be less stable. Am I correct or not? Yes. So what is the third condition which favors the formation of ionic bond? That is lattice energy. High lattice energy. High lattice energy. These are the three important criteria. One is low ionization enthalpy, high electron affinity, and the other one is high lattice energy. And there is one more that is called as, we'll study that separately in a rule called as Fajon's rule, but still I'll write it here. The last factor that might favor the formation of ionic bond is higher larger size of cation, larger size of cation and smaller size of anion. Smaller size of anion, okay, favors the formation of what? Ionic bond. This is called as which rule? Fajan's rule. Fajan's rule. Okay, larger the size of cation or smaller the size of anion, okay, it favors the formation of ionic bond. So these are the different factors which favors the formation of ionic bond. Which are the factors, students? That is, one, low ionization enthalpy. The other one is high electron affinity. The third one is high lattice energy. And the last one is large size of cation and smaller size of anion. According to which rule? Fajan's rule. Okay, so that's all about an ionic bond or electrovalent bond. Now let us talk about a covalent bond. Okay, let us talk about covalent bond. Yes, so covalent bond, students. Okay, what do you mean by a covalent bond? I know you have studied about covalent bond right from your lower classes, right from 7th or 8th standard. Okay, but still, what is a covalent bond? Let me define. Okay, a bond formed by okay, mutual sharing of electrons. Mutual sharing of electrons is called as what? A covalent bond, isn't it? A bond formed by mutual sharing of electrons is called as covalent bond. Let us take up the formation of hydrogen molecule. We have already discussed. Okay, let us take up the formation of hydrogen molecule. Okay, how is hydrogen molecule formed? Okay, one hydrogen atom will share one electron and the other hydrogen will share one electron. Now these two electrons belong to this hydrogen as well as this hydrogen, isn't it? Therefore a bond is formed between the two hydrogen atoms. And what is this bond formed? This bond formed is called as covalent bond. If you take up the formation of HCl molecule, hydrogen chloride molecule, how is hydrogen chloride molecule formed? How is HCl molecule formed? Hydrogen will share one atom and one electron, and chlorine will share one electron. Okay, now this electron or these two electrons is shared mutually between hydrogen and chlorine, belongs to both hydrogen as well as chlorine. Okay, it belongs to hydrogen as well as what? Chlorine. Now there is a bond formation between hydrogen and chlorine, and what is this bond called as? Covalent bond. Okay, so if a bond is formed by mutual sharing of two electrons, it is called a single bond. Okay, so there is single bond between the two hydrogen atoms. There is single bond between hydrogen and chlorine. Okay, if you consider oxygen molecule, how is oxygen molecule formed? See, one oxygen will share two electrons, the other oxygen will share two electrons. Okay, now these four electrons belongs to this oxygen as well as this oxygen. Now there is a bond formed between the two oxygen atoms, and how many bonds are formed between the two oxygen atoms? Okay, two electrons means one bond. So there are four electrons. Four electrons means how many bonds? Two bonds. So I can say that there is two covalent bond between two hydrogen atoms. There are two covalent bond between two hydrogen atoms, isn't it? Okay, if we consider the formation of nitrogen molecule, N2 molecule, how is nitrogen molecule formed? Okay, yes, one nitrogen will share 3 electrons, other nitrogen will also share 3 electrons. Now these 6 electrons belongs to this nitrogen as well as this nitrogen. Now a covalent bond is formed. How many covalent bonds are formed? 2 electrons means 1 bond. Okay, yes, so 1 covalent bond, 2 covalent bond and 3 covalent bond. Okay, so 3 pairs of electrons means 3 bonds. Okay, there are 3 covalent bonds between the 2 nitrogen atoms, isn't it? There are 3 covalent bonds between the 2 nitrogen atoms. So like this, a bond formed by mutual sharing of electrons is called as, what do you call this as? Covalent bond. Okay, so there can be 1 covalent bond between the 2 atoms, or 2 covalent bond between the 2 atoms, or 3 covalent bond between the 2 atoms. Yes, and remember one thing, students, covalent bond is directional. Didn't I say that ionic bond is non-directional? Yes, ionic bond is non-directional. Ionic bond is non-directional, whereas covalent bond is directional. I'll tell you what is directional and non-directional when I discuss the geometries of certain molecules. Okay, yes. Now, what are the characteristic features of covalent compounds? Yes. Okay, what are the characteristics of covalent compounds? Characteristics of covalent compounds. Okay, look, usually covalent compounds are, okay, they might be solids or liquids or gases, but ionic compounds they are crystalline solids. They are always crystalline solids, whereas covalent compounds might be solids, liquids or gases. Okay, they are perfectly insulators. They are insulators. They do not conduct electricity either in solid state or molten state or an aqueous solution. They are insulators. And then what? Okay, what are the other characteristic features? They are soluble in non-polar solvents here. Okay, they are soluble in non-polar solvents like benzene, okay, toluene, etc. They are soluble in non-polar solvents. Covalent compounds are usually soluble in non-polar solvents. Okay, now what are the factors that favors the formation of covalent bond? Okay, what are the factors that favor the formation of okay, covalent bond? What are the factors that favors the formation of covalent bond? Look here. Okay, what are the factors? The first factor is, see, okay, the combining atoms should have high ionization enthalpy. Okay, yes, the combining atoms should have high ionization enthalpy. See, for example, in hydrogen molecule H2, both the hydrogen atoms have high ionization enthalpy. If you consider hydrogen chloride, hydrogen and chlorine both have high ionization enthalpy. Okay, so like this, the combining atoms should have high ionization enthalpy. Okay, next, the combining atoms should have comparable, okay, electronegativity. Okay, should have comparable electronegativity. Comparable electronegativity means there should not be much difference between the electronegativities of the combining atoms. Okay, simple. So students, I'll continue with the characteristic factors that favors the formation of covalent bond in the next video also. Thank you.